Hello everyone and welcome back to the Intermediate Algebra video lectures. Today we are going to be covering our first bit of factoring, and today we are going to be factoring a special type of polynomial called quadratics, and those quadratics will be in the form of x squared plus bx plus c. So to get us started first, what is a quadratic? A quadratic is a polynomial of degree 2. What that means is that the highest exponent in a quadratic is 2. Now here is the definition of a quadratic. A quadratic function is a degree 2 polynomial in the form of a is x squared plus bx plus c, where a, b, and c here are just really any real numbers. The only exception is that a cannot equal 0, but b could absolutely equal 0, and c could also absolutely equal 0. So a, b, and c are just any real numbers. A is the coefficient of the x squared, b is the coefficient of x, and c is the constant with no variable. Now, when you have the quadratic written in the form of ax squared plus bx plus c, it is in standard form because the x squared term, the term with the highest exponent, is listed first, the exponents decrease, and the constant with no variable is on the end. Now, just as a recap of the factoring that we covered in the last video. So, two numbers that are being multiplied are called factors of the product. And this concept applies to both whole numbers and to polynomials. When you factor a whole number, you are writing it as the product of two other numbers. So if you break 12 down into 6 times 2, the act of writing 12 as 6 times 2 is called factoring. And both 6 and 2 are factors of 12. So in the case of polynomials, when you factor a polynomial, you are expressing the polynomial as the product of other polynomials. So factoring is the process of expressing a polynomial as the product of two or more other polynomials. Now, when you distribute factors, their product is the polynomial. So that also means that factoring is basically the reverse of distribution. It's distribution backwards. So therefore, you can always check your answer using distribution. If you distribute your answer and you get the exact same question back with absolutely no differences, including signs, then you did it right. If your answer is if your distributed polynomial is off a little bit, even if it's off by just a negative, that means you did something wrong in your factoring. Now, just like there are some prime numbers which have only factors that are 1 in themselves and cannot be factored, same goes for polynomials. If a polynomial cannot be written as the product of other polynomials, then it is called a prime polynomial. And what that means is that the polynomial cannot be factored. So we're going to start off by factoring quadratics where the leading coefficient is equal to 1. So where the leading coefficient is equal to positive 1, that means in that ax squared term, this a here would be equal to positive 1. So this is actually really easy. So to factor quadratics where the leading coefficient is 1, what you're going to essentially be doing is you're going to be looking for two numbers that multiply to the last number and add up to the middle number. Because if you remember when we were doing FOIL, a lot of the times we were able to combine the middle terms, we were able to add the middle terms together. So whatever goes here and whatever goes here, whatever goes here and whatever goes here, these last terms, the last terms need to multiply to the last number, and the two in the middle need to add up to the middle number. So factoring is going to basically be foiling backwards. So we're going to take the polynomial x squared plus 7x plus 12, and we are going to factor it, which means that we're going to write it as the product of two other polynomials. Specifically, we're going to write it as the product of two binomials. So what we are looking for are two numbers that multiply to the last number 12 and add up to the middle number positive 7. All right, so let's go through. What are two numbers that multiply to 12? Well, 4 times 3 is equal to 12, and 4 plus 3 is also equal to 7. So 4 and 3 are two numbers that multiply to 12 and add up to 7. So then to factor it, we're going to be writing it as the product of two binomials. So there's going to be one binomial here and one binomial here. Now remember, this is the reverse of distribution. This is the reverse of FOIL. So remember, the first terms, whatever goes here and whatever goes here, need to multiply to this first term, x squared. So what could you put in these first spots here that would multiply to x squared? And specifically, they're going to multiply to a 1x squared. So what could you put here and here to multiply to 1x squared? Well, you could put an x here and an x here, because x times x will give you x squared. Now remember, the last terms need to multiply to the last number. So if you put the positive 4 here and the positive 3 here, what will happen is when you distribute, you're going to multiply, the last terms will multiply to 12, and the middle terms, the O and the I, will add up to 7. Now, if you want to check your answer, you can always check your answer by distributing. So if you just distributed this answer really quick, x times x is x squared, x times 3 is plus 3x, 4 times x is plus 4x, and then 4 times 3 is plus 12. And then when you combine the middle terms, 3x plus 4x will give you 7x. So because you got the exact same polynomial back with absolutely no differences, that means this is the correct answer, and this is your polynomial fully factored. Now, I know what you might be thinking. Did I need to list the 4 first? And the answer is no. Remember, there is hidden multiplication between these two factors, so order doesn't matter with multiplication. So if you wanted to, you could write this as x plus 3 times x plus 4, and it's not going to make a difference. If you FOIL this, you're still going to get x squared plus 7x plus 12. So it doesn't matter if you list the plus 4 first or the plus 3 first. It really doesn't matter. What does matter is that both the 4 and the 3 are both positive. So as long as the 4 and the 3 have the correct signs, it doesn't matter which factor is listed first. Either of these would be considered a fully correct answer. So then we're going to do the next one. So for x squared plus 7x plus 10. First of all, let's check to see that the leading coefficient is 1. And since there's nothing to the left of this x squared, the leading coefficient is 1. So when the leading coefficient is equal to positive 1, to factor it, all you have to do is look for two numbers that multiply to the last number, 10, and add up to the middle number, 7. So let's figure out what two numbers multiply to 10 and add up to 7. Well, two numbers that multiply to 10 are 5 and 2. And if you were to add 5 and 2 together, you get 7. So I'm going to set up my two binomials, one binomial here, one binomial here. And remember, whatever goes in the first spots here and here needs to multiply to a positive 1x squared. So if you put an x here and an x here, x times x will give you x squared. Then both the 5 and the 2 are positive, so I'm going to put a plus 5 here in this factor and a plus 2 in this factor, because 5 times 2 gives you 10, and 5x plus 2x will give you 7x. And remember, it doesn't matter the order that you list them in. If you wanted to, you could write this as x plus 2 times x plus 5, and it does not make a difference. These are the exact same. Now, as soon as you start throwing negatives into the mix, you do have to start thinking about, okay, what are my rules for multiplying negatives and what are my rules for adding negatives? So if we're looking at x squared minus 6x plus 8, let's first take a look at the leading coefficient, the number that is in front of x squared. Because the number in front of x squared is a positive 1, that means the factoring just involves you looking for two numbers that multiply to the last number, positive 8, and add up to the middle number, negative 6. All right, so let's first go through two numbers that multiply to 8. Now, in order to multiply to a positive, if you remember when you learned how to multiply negatives, that in order to multiply to a positive, the factors have to have the same sign. So if the two factors have the same sign, their product is going to be positive. Now, the only two ways that you can multiply two numbers together and come up with a positive 8 is for them to have the same sign. So either a positive 4 and a positive 2, Or the alternative is a -4 and a -2. Now, which of those two pairs of numbers is going to add up to that middle number, -6? It's going to be this one. So in order to multiply to a positive and add up to a negative, both of the factors have to be negative, because a negative times a negative is a positive, and a negative plus a negative is a negative. So here's what that's going to look like. Here's one binomial here, one binomial here. In order to multiply to a positive 1x squared, there needs to be an x here and an x here. One of your factors is going to have a -4, and the other one is going to have a -2. And if you want to check your answer, remember you can always check your answer using distribution. So if you do x times x, we get x squared. X times -2 is -2x. -4 times x is -4x. And then -4 times -2 is +8. So then when you add the two middle terms together, -2x plus -4x is -6x. So in order to multiply to a positive and add up to a negative, both factors need to be negative. And remember, you can switch these as long as the 2 remains negative and the 4 remains negative. So then for this next one, for x squared minus x minus 12. Because the leading coefficient is a +1, that means that all you have to do to factor is look for two numbers that multiply to the last number, -12, and add up to the middle number, which is -1. So when you are multiplying to a negative, this was going to get a little different. In order to multiply to a negative, the factors need to have different signs. So in order to multiply to a negative, one of the factors needs to be positive and the other factor needs to be negative. So there's a couple of options that we have here. One way to multiply to -12 is to multiply +3 and -4. Another way to multiply to a -12 is a -3 and a +4. Now remember, they have to add up to -1. So which of those two pairs of factors are going to add up to -1? +3 and -4 are going to add up to -1. So +3 and -4 are two numbers that multiply to -12 and add up to -1. So I'm going to set up my two binomials. In order to multiply to a 1x squared, there needs to be an x here and an x here. One of the factors is going to have a +3, and the other factor is going to have a -4. And remember, you can reverse these as long as the 4 remains negative and the 3 remains positive. It's not going to make a difference which factor is listed first. So either of these are going to be your final answer. So a couple of general tips when you're dealing with negatives. If the sign of the last number is positive, then the factors are going to have the same sign. They're either both going to be positive or they're both going to be negative. And which one they are is really dictated by the middle number. If the middle number is negative, like in this last one, that means both of the factors are going to be negative. So if the sign of the last number is positive, then the factors are going to have the same sign, and if that middle sign is negative, they're both going to be negative. Now, if the sign of the last number is negative, then the factors are going to have different signs. One of the factors is going to be positive, and the other factor is going to be negative. Now, if you notice, for this last one, the middle number was a -1, and the larger of the two factors was negative, and that's not an accident. When your sign of your last number is negative and the factors have different signs, the larger factor is going to take the sign of the middle number. So if the middle number is negative, the larger factor is going to be negative. If the middle number is positive, then the larger factor is going to be positive. So I want you guys to try these two for yourselves. There's a couple of negatives in here, and remember, if the sign of the last number is negative, the factors are going to have different signs, and the larger factor is going to take the sign of the middle number. So I want you guys to try these two. I want you to factor x squared plus 4x minus 12 and x squared plus x minus 56. So go ahead and pause the video and resume when you are done working and ready to check your answer. Okay, so for this next one, we are looking, since the leading coefficient is equal to positive 1, we are looking for two numbers that multiply to the last number, negative 12, and add up to the middle number, positive 4. So if you've tried 4 and 3, 4 and 3 don't work. So let's try 6 and 2. So the two ways that you can multiply to a negative 12, remember the only way to multiply to a negative is for the factors to have different signs. So you have two options here. You either have a negative 6 and a positive 2, or you can have a positive 6 and a negative 2. Which of those two pairs of factors are going to add up to positive 4? And that's going to be this group over here. Positive 6 plus negative 2 is positive 4. So we're going to set up our two binomials. In order to multiply to a 1x squared, there needs to be an x here and an x here. And then one of the factors is going to be a positive 6, and the other one is going to be a negative 2. Now remember, if you had these reversed, that's fine, as long as the 2 is negative and the 6 is positive. And remember, if you ever want to check your answer before submitting it, you can always check your answer by distribution. And then for this last one, because this is a positive 1, the leading coefficient is a positive 1. That means to factor, all we have to do is look for two numbers that multiply to the last number, negative 56, and add up to the middle number, positive 1. So in order to multiply to a negative, the factors need to have different signs. One of the factors needs to be positive and the other factor needs to be negative. So there's two ways to multiply to negative 56. We can either have a positive 7 and a negative 8, or we could have a negative 7 and a positive 8. Which of those two is going to add up to positive 1? Negative 7 plus positive 8 is going to add up to positive 1. So in your two factors, in order to multiply to a 1x squared, there needs to be an x here and an x here. One of the factors is going to have a minus 7, and the other one is going to have a plus 8, and then that is your final answer. So that is the general gist when you are factoring and the leading coefficient is equal to positive 1. So if you're factoring a quadratic and the leading coefficient is positive 1, that means that all you have to do are look for two numbers that multiply to the last number and add up to the middle number. So I want you guys to give these next two a try. I want you to factor these and go ahead and pause the video and resume when you are done working. Okay, so for this next one, because the leading coefficient is equal to positive 1, we are looking for two numbers that multiply to the last number, negative 36, and add up to the middle number, negative 5. If you've noticed, 6 and 6 do not work. So you're going to look for another pair of factors that multiply to negative 36. So another pair of numbers that multiplies to 36 is 9 and 4. So we can either have a negative 9 and a positive 4, or to multiply to a negative, we could have a positive 9 and a negative 4. Which of those two pairs of factors is going to add up to negative 5? And that is going to be this one. Negative 9 plus 4 is equal to negative 5. So one of your factors is going to have an x minus 9, and the other factor is going to have an x plus 4. So then for this last one, Because the leading coefficient is equal to positive 1, that means we are looking for two numbers that multiply to the last number, positive 20, and add up to the middle number, positive 9. Well, since everything is positive, we don't have to worry about any negatives here, because in order to multiply to a positive and add up to a positive, that means both of the factors need to be positive. So two numbers that multiply to 20 are 4 and 5, and 4 plus 5 also gives you 9. So one of your factors is going to be x plus 4, and your other factor is going to be x plus 5. So then for these next two, I'm going to go through these next two with you. Remember, if you want to ever attempt a problem before I go over it, just feel free to pause the video and resume when you are done working. But this last one is going to kind of lead us into the next section here. So for x squared minus x minus 42, because the leading coefficient is equal to positive 1, that means that we are looking for two numbers that multiply to the last number, negative 42, and add up to the middle number, negative 1. So two numbers that multiply to negative 42. Well, in order to multiply to a negative, the factors need to have different signs. One of them needs to be positive and the other needs to be negative. Now, two numbers that are close together that multiply to negative 42 are 6 and 7. And remember, the larger factor is going to take the sign of the middle number. So since the middle number is negative, the larger factor is going to be negative. And positive 6 plus negative 7 is going to give you negative 1. So one of your factors is going to be x plus 6, and the other factor is going to be x minus 7. So then for this last one, for x squared plus 4x plus 4, because the leading coefficient is equal to positive 1, we are looking for two numbers that multiply to the last number, positive 4, and add up to the middle number, positive 4. Now this one's really easy to do. Two numbers that multiply to 4 and add up to 4 are 2 and 2. So one of your factors is going to have an x plus 2, and the other factor is also going to have an x plus 2. Now, writing it like this is perfectly fine, but one way that you could simplify this further is if your two factors are exactly the same, which these two are. These two factors are exactly the same. Remember, you can always write repeated multiplication as an exponent. So you can write x plus 2 times itself as x plus 2 quantity squared. And in fact, we're going to prefer you to write it this way because repeated multiplication can always be written as an exponent. Now remember, the only reason that you can do this is because the two factors are exactly the same. And that is going to be something called multiplicity, which we're going to get into a little bit later. Now, you also might remember that we spent the entire first video in this chapter talking about greatest common factors. So for a greatest common factor, I'm just going to recap. I mean, this is the exact same slide as in the last video, but I'm just going to recap what a greatest common factor is because greatest common factors, they haven't gone away. We haven't covered them yet. But greatest common factors are always something that you should just always look for anytime you start any sort of factoring problem. Now, for common factors, you should ask yourself, does every single term in this polynomial have something in common? Are all of the coefficients divisible by the same number? Do all of the terms contain the same variable? If every single term in the polynomial contains a common factor, then we say that there is a greatest common factor. And we spent a lot of time in the previous video talking about how to factor out common factors. Now, at this point, now that you have some idea of how to finish factoring a polynomial, after you factor out the greatest common factor, the polynomial may be able to be factored further. Now, if a quadratic ever contains a GCF, a greatest common factor, you should always factor that out first before doing any other factoring. Another thing with common factors is if the leading coefficient is ever negative. You might have noticed that factoring is really easy to do as long as your leading coefficient is positive 1. Now, if your leading coefficient is, let's say, negative 1, it's a lot harder to factor as it is. So there is an easy fix if your leading coefficient is ever equal to negative 1. What you will do is you will factor out a negative GCF first. If there are other GCFs, you're going to factor those out as well, but if there's no other GCFs and your leading coefficient is a negative, then at the very least you're going to factor out a negative GCF first. What that will essentially do is change all of the signs in the polynomial. Then once you have factored out the negative GCF, then you're going to factor what's left over in the parentheses just like you normally would. So looking at this next one, you might notice that the leading coefficient is not positive 1. The leading coefficient is negative 1. So we have to deal with that first before we can even think about doing any other factoring, because factoring is going to be a lot harder if your leading coefficient is negative. Now, if you take a look at this, so you have negative 1, negative 2, and 15. They're not all divisible by the same number besides negative 1, and not every single term has the same variable. So there's no other common factors here, but what we are going to do is to fix this issue with the negative 1 in front, we are going to factor out a negative 1 first. And what that will involve is we're going to write the negative 1 out front, put the rest in parentheses. And what I'm going to do is I'm going to divide each of these terms by negative 1. And because we are not factoring out any variables, we're going to leave all variables and all exponents completely alone. So negative 1 divided by negative 1 is positive 1 x squared. Then negative 2 divided by negative 1 is positive 2, and you're going to leave the x alone. Then positive 15 divided by negative 1 is negative 15. So now that we factored out the negative 1, we're going to leave that negative 1 where it is, but we're going to ignore it for right now, and we're going to focus on what's in the parentheses. So we're going to focus on our new numbers inside the parentheses. And you might notice that inside the parentheses, your leading coefficient is now equal to positive 1. So because your leading coefficient is now equal to positive 1, now you can factor like you normally would by looking for two numbers that multiply to our new last number, negative 15, and add up to our new middle number, positive 2. So you're going to use the numbers that are in the parentheses for this. The new last number is negative 15, and the new middle number is positive 2. Now remember, in order to multiply to a negative, the factors need to have different signs. One needs to be positive and one needs to be negative. So two numbers that multiply to 15 are 5 and 3, and the larger factor is going to take the sign of the middle number. So since the middle number is positive, the larger factor is going to be positive, and the smaller factor is going to be negative. Positive 5 plus negative 3 will give you positive 2. So that negative that you factored out, you're going to leave it there. You don't have to write the 1 technically, but you do need the negative there. So you're just going to leave your GCF there. Then you're going to finish factoring. Because this is now a positive 1x squared, there's going to be an x here and an x here. One of your factors is going to have a plus 5, and your other factor is going to have a minus 3. So whenever you factor out a GCF, you're just going to leave the GCF out front, and it's just going to kind of stay there and get carried along through the rest of the problem until your final answer. And then you're going to factor what's in the parentheses like normal. So that is the general gist for factoring out GCFs first. Now, for this next one, we have negative 3x squared plus 9x plus 12. You might notice that there's a couple of problems with this. First, the biggest one is that the leading coefficient is definitely not positive 1. In fact, the leading coefficient is negative 3. So first of all, because the leading coefficient is negative, it is a lot harder to factor as is. So when your leading coefficient, the number in front of x squared, is negative, you at least need to factor out a negative GCF. Now you should also look for any other GCFs while you're at it. So take a look at the numbers negative 3, 9, and 12. What is the largest number that goes into all three of those? Well, the largest number that goes into all three of those is 3. So I'm going to not only factor out a negative, but I'm also going to factor out a 3. So I am going to factor out a GCF of negative 3 first, before doing any other factoring. So I'm going to put the negative 3 out front and put all of the leftovers in parentheses. And what I'm going to do is I'm going to divide each of these terms one at a time by -3. Remember that if you are not factoring out a variable, which we're not, you're going to leave all variables and all exponents completely alone. So -3 divided by -3 is +1x squared. Then +9 divided by -3 is going to give us -3, and you're going to leave the x alone. Then +12 divided by -3 is -4. So once you have factored out your GCF, that GCF is just going to stay there for the rest of the problem, so that -3 is just going to be part of the final answer. And what you're going to do from here is you're going to focus on what's in the parentheses. So now what's in the parentheses, the leading coefficient is now +1. So because the leading coefficient is now +1, now we're going to look for two numbers that multiply to our new last number, -4, and add up to our new middle number, -3. So in order to multiply to a positive, the factors need to have different signs. Now 2 and 2 don't work because +2 and -2 are always going to add up to 0. What's another pair of numbers that multiplies to 4? The only other pair of numbers that multiplies to 4 are 4 and 1. So yes, the 1 and itself factor is occasionally used. Now in order to add up to a -3, if we had a -4 and a +1, that will add up to -3, because remember, the larger factor is going to take the sign of the middle number. So I'm going to leave my GCF where it is. I'm just going to leave it there, and I'm going to set up my two binomials. In order to multiply to a 1x squared, there needs to be an x here and an x here. One of the factors is going to have a -4, and the other factor is going to have a +1. And then that is going to be your final answer. Now remember, the only time that you need to factor out a -1 is if the leading coefficient is negative. So for this next one, I'm going to let you guys try this one, but I will give you a hint. The leading coefficient is positive. So because the leading coefficient is currently positive, you do not have to factor out any negatives. But if you do look at the numbers 2, 12, and 16, what is the largest number that goes into all of those? They are all divisible by 2. So you guys are going to factor out a +2 first. You don't need to factor out any negatives because the leading coefficient is not negative, it's positive. All right, so I want you guys to pause the video and finish this one and then resume the video when you are done working. All right, so for this one, we're going to first factor out a +2 first, put the leftovers in parentheses, and because we are not factoring out any variables, we're going to leave all variables and exponents alone. So 2 divided by 2 is +1, leave the x squared alone. Then +12 divided by +12 divided by +2 is +6, and you're going to leave the x alone. And then 16 divided by 2 is +8. So that GCF that you took out, you're just going to leave it there, and it's going to be part of your final answer. But for the rest of the factoring, you're going to focus on what's in the parentheses. Now, what's in the parentheses, the leading coefficient is now +1. So because our new leading coefficient is +1, now we are looking for two numbers that multiply to our new last number, +8, and add up to the new middle number, +6. All right, so since everything is positive, in order to multiply to a positive and add up to a positive, that means both of the factors need to be positive. Two numbers that multiply to 8 are 4 and 2, and 4 plus 2 does indeed give you 6. So you're just going to leave that GCF alone, and you're going to set up your two factors. Because your leading coefficient is now +1, there is an x here and an x here. One of the factors is going to have a +4, and the other one is going to have a +2. And remember, if you had these switch, that's fine, as long as the 4 is positive and the 2 is positive, and as long as that GCF remains part of your final answer. So then that is now fully factored. So then I want you guys to also try this next one. Now remember, if the leading coefficient is positive, you do not need to factor out any negatives. And if there is more than one common factor, you need to factor out the greatest common factor. So you're looking for the largest number that goes into 4, 28, and 24. So go ahead and give this one a try and resume the video when you are done working. All right, so the largest number that goes into all three of these is 4. So I'm going to factor out a positive 4 first, and I'm factoring out a positive 4 because the leading coefficient is negative and I do not need to factor out any negatives. So 4 divided by 4 is 1 and leave the x squared alone. 28 divided by 4 is positive 7 and leave the x alone. And then 24 divided by 4 is positive 6. So that GCF of 4 is just going to be part of your final answer, and you're going to now focus on what is in the parentheses, and you're going to factor what's in the parentheses. So because your new leading coefficient is positive 1, all you have to do to factor is look for two numbers that multiply to the new last number, positive 6, and add up to the new middle number, positive 7. Now, if you had tried this one, you might have noticed that 3 and 2 don't work. 3 and 2 add up to 5. So when that happens, look for another pair of numbers that multiplies to 6. Another pair of numbers that multiplies to 6 is 6 and 1. And 6 plus 1 does indeed give you 7. So this is another instance where the 1 and itself factor is the one that actually works. So you're going to leave your GCF alone, leave it out front, and set up your two binomials. In order to multiply to a positive 1x squared, there needs to be an x here and an x here. One of your factors is going to have a positive 6, and the other factor is going to have a positive 1. And then that is going to be your final answer. So then for this last one, I'm going to do this last one with you because there's a couple of different GCFs. Now take a look at the leading coefficient. And I need my pen back. So if you take a look at the leading coefficient is positive. So because the leading coefficient is positive, you do not need to factor out any negatives. But let's take a look for some GCFs. We have positive 3, negative 6, and positive 3. What number goes into all three of those? Well, all three of those are divisible by 3. And if you look at each of the terms, we have x cubed, x squared, and x. Every single one of these terms contains the same variable. So there is a variable GCF here. And remember, when your GCF is a variable, the power on your GCF is the lowest power of x that appears. So since the lowest power of x that appears here is 1, your greatest common factor is going to be 3x to the power 1. So what I'm going to do is I'm going to factor out a 3x first and put the leftovers in parentheses. I'm going to divide all of the coefficients by positive 3, and I'm going to subtract all of the exponents by 1. Remember, anything divided by itself is 1, and anything to the power 0 is also equal to 1, and x to the power 0 will effectively cancel out. So here we go. 3 divided by 3 is positive 1, and then 3 minus 1 is x to the power 2. Then negative 6 divided by 3 is negative 2, and then 2 minus 1 is x to the power 1. And then 3 divided by 3 is positive 1, and you do need something here. And then 1 minus 1 is x to the power 0, and x to the power 0 cancels out. Now remember, you don't want to leave this blank. 3 divided by 3 is positive 1, so you do need to indicate that the entire last term just became 1 when you factored out the 3x. So then that GCF of 3x is just going to stay there and be part of your final answer, and then you're going to finish factoring what is in the parentheses. So because the leading coefficient is a positive 1, that means all we have to do to factor is look for two numbers that multiply to the new last number, positive 1, and add up to the new middle number, negative 2. All right, so there's not much that multiplies to 1. Now remember, in order to multiply to a positive, your two factors need to have the same sign. They either both need to be positive or they both need to be negative. And since the middle number is negative, that means your two factors need to both be negative. So -1 times -1 will give you +1, and -1 plus -1 will give you -2. So I'm going to leave the 3x where it was, and I'm going to now set up my two factors. Because the leading coefficient is +1, there is an x here and an x here. One of your factors is going to have a -1, and the other factor is also going to have a -1. And remember, when you have two factors that are exactly the same, that is repeated multiplication, and repeated multiplication can always be written as an exponent. So just to simplify this a little bit further, I'm going to write this x minus 1 times itself as x minus 1 parentheses squared. And then this is going to be your final answer. So that is the first part of factoring. I will make the disclaimer that this method of factoring only works when either your leading coefficient is equal to +1, or if it's not +1, if factoring out a GCF makes it +1. There are going to be plenty of instances later where even if you factor out a GCF, the leading coefficient will not be -1. Or there may not be a GCF at all and your leading coefficient is not +1. So there are going to be plenty of instances where the leading coefficient is just not +1, and that is going to involve a different method of factoring, and that is what we're going to cover in the next video. So stay tuned for that. Thank you all very much for watching this video, and I will see you for the next video where we're going to factor quadratics where the leading coefficient is not +1.